4.1 notes, basic probability. Theoretical probability, given the image of all possible outcomes for rolling 2 dice, we can determine the theoretical probability of finding any given sum from blank to blank. So what's the lowest sum you could get when rolling 2 dice? 2, and the highest?
12.
Good. From 2 to 12. So example 1 asks, what is the probability of rolling a sum of 8? Step 1, find the number of total possible outcomes. So we would say, how many total possible outcomes are there in rolling 2 dice? Looking at all the different possibilities, how many different possibilities are there?
36.
Good, 36. And then we're going to make a ratio of the number of ways that our event can occur divided by the total number of possible outcomes. We just said that was 36. So now we're looking for how many ways can we roll an 8. So I see here's an 8, an 8, an 8.
So, an 8. 5.
5 ways, okay, there we go. 5 out of 36. Step 3 says simplify, so we can write our answer. We could write it as a simplified fraction or as a decimal. So go ahead and calculate 536 as a decimal. We know we just divide the numerator by the denominator. What do we get?
0.13 repeated.
So we'll go with 0.139. Sometimes you write probabilities. Technically, we should write them as a reduced fraction or as a decimal. So we'll stick with that, 0.139. In the example above, notice all chances are equally likely to occur. Notice that we called rolling a sum of 8, we called that an event, or the event. We called it that right here when we said the event. So the probability for equally likely outcomes, or the F over N rule, is the number of ways the event can occur over the total number of possible outcomes, like we just did, or lowercase f over capital N. Lowercase f standing for frequency over N, the number of possible outcomes. The science of uncertainty is called blank blank. It's at the top of your paper. Probability theory. Probability theory provides the mathematical basis for inferential statistics. That's what we just finished doing, right? When we talked about our normal curve and our confidence intervals, we were using inferential statistics, like just looking at a sample of the population and then making inferences about the total population based on our different criteria. So probability theory is the foundation for all of that. So recall, inferential statistics is used in making decisions based on the likelihood that an event will occur. And here we have 3 properties of probabilities. Basic properties of probabilities. I'm going to call it random for you to read. Property number 1, please read for us. Krista.
The probability of an event is always between 0 and 1.
Inclusive.
I'm sorry, I don't have my glasses.
Good, so inclusive, so that means we include 0 and 1. So 0 and 1 are possible options for probabilities. And property 2, read for us, please, Rose. such as the Bengals winning the Super Bowl, something like that.
Whatever.
Property, probability, impossible event. Yes? Yes, thank you.
The probability of an event that must occur is more an event that is must occur is
Certain event, such as the Bengals losing in the first playoff game. Probability of one. I'm just looking at statistics. True, they have to make it, but if they make it, the probability that they, I don't know if you saw your last night's. I'm just joking. It's a rough day. We love the Bengals. Go Bengals. It's true. The Cincinnati Bearcats, however, did win on Saturday, so I'm rooting for the Bearcats.
not the Bengals.
I'll be a loyal fan, but it's really tough right now.
I mean, I'm not a football guy. I'm more of a basketball guy.
All right, example 2, since I'm being recorded right now. Which of the following could possibly be a probability? 5, 6. Could that be a probability? Raise your hand if you believe that it could. You're correct, because 5, 6 is between 0 and 1 inclusive. 3.5, raise your hand if you think that could be a possible probability. Nope. Why not? Nathan?
Not between 0 and 1.
Good, it's bigger. And C, could we have a probability of 0? Raise your hand if you agree that we could have a probability of 0. You are correct, because we talked about that already. It has a special name called the impossible event. Experimental probability. Let's talk about theoretical. Now we're talking about the experimental. Doing an experiment or simulation and then calculating the probability is called experimental probability. Also known as simulated. So there are all kinds of simulations you can find online. We could get out 2 dice and roll them and see how long it takes us to get 12, a sum of 12. Or we could find simulation dice online and we could hit a button and it would roll the dice for us. So those are the 2 kind of experimental simulation, same kind of concept. Real world factors play into this type of probability, gravity, friction, economy, weather, etc. So your experimental probability and theoretical probability, rarely are they exactly the same, right? So we know if I can 25% of the time make a basket from the free throw line and I try 4 times, theoretically I should make one of those. But in real life, anything goes, right? So we can, oh, this guy's up. He's shooting free throws. He's going to make it because he has a good chance. It doesn't depend on anything. Each chance is equally likely. Anything goes. So calculate the theoretical probabilities of the scenarios below. Example 3, will you read that for us, please? Alyssa?
A polling firm hired to estimate the likelihood of the passage of an upcoming referendum obtained a set of survey responses to make its estimate. The encoding?
Mm-hmm.
The encoding system for the data is 1 equals 4, 2 equals against. If the referendum were held today, find the probability that it would pass.
Good. So super complicated code here. If you have a 1, it means you were for the referendum. If you have a 2, it means you were against the referendum. So we're counting up the number ones. How many number ones are there?
12.
12. And how many total votes were there?
20.
Good. So 12 out of 20. We could write that as 3/5. We could write that as a decimal. What would be the decimal? 0.6, good, 6/10. Example 4, if two balanced die are rolled, the possible outcomes can be represented as follows. Same thing as the front, it's just instead of using pictures, we use ordered pairs here. So let's go ahead and find the probability that the sum of the dice is 10. So go ahead and try that on your own. How many different ways can we get a sum of 10?
3 out of 36 or 1 out of 12.
3 out of 36, 1 out of 12, or what decimal? 0.84?
Yeah. It's actually 0.083333.
Example 5. Read that for us, please, Gwen.
An experiment has 70 possible outcomes, all equally likely. An event can occur in 2 ways. Find the probability that the event occurs if your answer is integer or decimal.
When it says that, the only possible integers you could write there would be 0 and 1. Okay, otherwise it's a decimal. So what would be the fraction that we would write there first, Gwen?
18/70.
Yep, 18/70. And let's go ahead and write that as a decimal.
.26.
Anyone else agree?
Is there any particular way you want things rounded up? Because like sometimes you'll round up to 3 decimal places and sometimes you'll round up to 2. Then you're like,
Unless it says so, no.
okay. But like for like example on a test or something, what would you?
I like 3 decimal places.
Okay.
Here I've just kind of gone with whatever someone says.
Yeah. No, I was just.
Yeah. Example 6. Read that one for us, please, Michael.
To the right are 6 of the leadership roles in the Eagle Scout. List all possible outcomes without replacement of size 4 that can be obtained from the population of 6 leaders. And there are 15 possible outcomes.
Are you ready for this? This is like a mind game right here. Anybody do Sudokus or crossword puzzles? Trying to find all of the different ways that you can arrange these letters. If you feel confident to do this on your own, you can try it. Otherwise, you can watch me as I try and do it. So here we go. P, I'm going to just use the first letters. And I try and keep some sort of a system here, so I'm just going to go down the line. P-A-G-D. And then I'm going to keep my first 3 letters and just change the last letter. P-A-G-H, P-A-G-S. P-A-G-D, P-A-G-H, P-A-G-S. And then I don't think I can do anything else with P-A-G, so I'm going to do P-A-D. P-A-D-H, P-A-D-S. And then I'm going to move on to P-A-H, S.
Would you not do P-A-D-G?
P-A-D-G. I already did that here. D-G and G-D are the same. So P-A-H-S. Now I can't do any more P-A's, so I'm going to move on to P-G. P, G, D, H, and then P, G, H, S. And then any other PGs that I can do? So then P, D, P, D, H, S. I think that's all the P's I can do. So then I move on to A. A, G, D, H. A, G, D, S. And then A, G, H, S. I don't think there's any more A, so then A, D, H, S. And then lastly, let's see, we did all the A's, we can do G, D, H, S. I have 14. This is what happens. So then I have to go back and you have to find it. Maybe one of you all found all of the ones and can find the one that I missed. Did I do PGDS? I missed PGDS. So there you go. I think there's one like this on your homework. So there's 15 total possible ones. It does start to make you go cross-eyed, but I believe in you. At least there's not 100. So, if a simple random sample without replacement of 4 liters is taken from the 6 liters, determine the probability of the following liters in the sample. So, what is the probability that you would have a senior patrol leader, a troop guide, and a den chief? So, we're looking for the letters P, T, no, not T, G. P, G, and D. So here's a PGD, 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 and a PGD. So I see 3 out of a total 15, or 1/5, or 0.2. So how many then for C, the senior patrol leader and den chef? Did I say den chief last time?
I was just laughing because there's the den chef. I'm den chef to the Eagle Scouts.
All right, so the Eagle Scouts is a big deal. So PD, you're looking for how many times does PD occur in our out of our set of 15? 6 out of 15.
Don't they have to be right next to each other?
No.
6. You're at 6. It's 6.
So PD, we have a PD here, a PD here, a PD here, PD,
Mark the bottom.
and PD. There you go. Nice. And then senior patrol leader, so just P. How many times does just P occur out of our 15?
9,
10.
10?
10. Sure.
10 out of 15. So that concludes our notes on probability, the basics of probability, theoretical and experimental. Any questions?